Okay, I think we will kick off. So again, thank you very much to all of you that have joined this afternoon to another installment in our weekly webinar series. And today, John, this is one that I'm particularly excited about as we dive into the very first installment in our Threat360 technical webinar series. And today we're looking at threat-informed defense and how do you approach it? And really it's to better refine your defenses to defend against your threat landscape. We'll go into that a little bit later. But it's critically important that all of us assess the threat landscape and also validate that we're able to defend against it. So rather than purely talk about it today, we're going to get hands-on and live. So let's hope that we don't fall foul of any of the live gremlins. And we're also going to use a real-world threat actor, Fox Kitten. And this is going to allow us to pivot our conversation around that real-world actor and to cover why that is important to us. So without further ado, I will introduce my co-presenter for today to guide us through this. So just move the slides on here. Hopefully. There we go, our first technical gremlin there. So I'd like to welcome Mark Standish to this webinar. So Mark is an expert in cyber threats, threat intelligence, and threat detection. He spent his early career in the National Health Service and BUPA, so the health service in the UK, protecting healthcare services and also critical national infrastructure. And that's before moving into managed services. Mark leads our threat content team, using his expertise in detection engineering and automation to build our detection response programs and tooling. Mark then continues to evolve our detection as code platform, which he built to continually deliver threat-informed defense to our threat detection and response customers. So welcome, Mark, today. And we'll now move to the agenda. So what are we going to cover today? So we're going to cover what to expect from this session. So get down into the detail of what you can expect to learn, what you can expect to hear. We're going to go through what do we actually mean by threat landscape? I hinted during my intro that, about your threat landscape, and we'll dive into that. And we'll also dive into other elements around TTPs. We're going to look at what threat-informed defense actually is, and then how do we use that to create an adversary profile? And then also, how do we turn that profile into a defense capability? And then we'll wrap up and jump into Q&A. So please, if you do have questions as we run through this webinar, please ask them and we will answer those at the very end of the session. So before we kick off, we want to kick off with a poll question. And this is really to get the views and your views on threat-informed defense. So that question, if we can launch that now, and I'll give you a minute to answer just while we walk through this. But the question is, are you using threat-informed defense to defend your business? And our options are yes, we have built a fully functioning tool set that regularly tests our defensive capabilities. Yes, but only ad hoc. We carry out occasional reviews against the threat landscape. No, but it's something we're looking to do or would like to do. No, we have no plans for it. Or finally, no, threat-informed defense is not a concept I'm aware of. So we'll leave that open for a minute. But in the meantime, I'm going to hand control back over to Mark so he can kick things off. Mark, over to you.
Hey everyone, and thank you for the introduction, Rich. So the objective of today, just very quickly, we all hear terms like threat landscape and TTP thrown around all the time by different vendors, and we rarely stop and think what the terms actually mean, how to apply them best. So the idea within this session is that we're going to do a quick deep dive on the key terms like threat landscape and start dissecting the TTP as a method for tracking adversary behavior before explaining how these concepts can be applied proactively to improve each of our defenses. We'll demonstrate particularly how anybody could leverage free and reputable resources to build their own threat-informed defense toolset. So by the end of the session, our hope and objective is that the audience will have a clear understanding of what threat-informed defense is, what the strategic benefits are, and how somebody could start their own threat-informed journey and build a practical tool set without buying into any new tech or tool set subscriptions, what have you. I'm going to start off with an analogy which might seem like a bit of a reach, but if you could just bear with me for a moment, I'd ask each of you to imagine yourself as a painter tasked with depicting a medieval battle. The landscape involves everything from the armies rallying and the weapons they carry to the slope of the hill and the temperature of the day. A really good painter or a great painter has to tell every detail so that the audience can start to understand the context of the battle, down to the zeitgeist of the era, the cause of the conflict. For instance, in the picture on screen, we've got church and crown, we've got swords, we've got slopes, we've got forest. All of these things contribute important context to our picture. Each battle presents both armies with a range of internal and external factors. So regardless of the soldier's control over each factor, each detail contributes important context. I would now ask you to try and paint a mental image of the battlefield that your own organization sits on today. So in modern security terms, we describe external factors like technological advancements, socioeconomic climates, political dynamics. And these are all the things that are relatively hard to govern, but are crucial to consider. An example of a well-documented technological advancement that changed the battleground for each of us was the adoption of cloud. So we all broadened the publicly available attack surface of our organization, and it's something that's really had an impact on defense and offense. A less well-documented shift that we're starting to see now is the impact of agentic AI. Phishing and vishing is getting really good, and I don't know if we've necessarily got all of the countermeasures in place to deal with that yet, something that we all need to think about. Similarly to the technological advancements, we can think about economic sanctions and tariffs that we're seeing in America at the moment. You know, these sorts of things apply a lot of interest to US critical national infrastructure. We just all need to think about the external factors in which we're operating in order to build effective defenses. On the other hand, we've got a whole host of internal factors at play, and these are things like our operational tooling of choice, our organizational culture, general security awareness, defensive controls, and the subject of today's conversation really is a facet of those controls is our MDR or MTD, threat detection, threat response capabilities. So for the purpose of today's discussion, we're focusing predominantly on improving detection and response capabilities as a facet of a holistic cyber program. But the concepts that we're talking about in this demonstration apply across the board, right? If it's awareness programs or hardening exercises, we need to be thinking about our threat landscape as a informant of effort prioritization. So what is threat-informed defense? Another labored quote there from Sun Tzu, but it's labored for a reason. It's incredibly appropriate. Particularly among engineers and developers, we often find ourselves maybe too focused on developing and maturing a particular technology, and we get a little bit lost in zeros and ones. There was a good quote from the Korean economist Ha-Joon Chang recently, who critiqued modern economics by saying we've collectively substituted maths for critical thinking. And I think we kind of do a similar thing as engineers. There's so many engineers who spend all of their time trying to configure or roll out the latest feature set for their tool, and we kind of forget why we're doing any of it to begin with. It's just generally easy to lose sight of the big picture when you're lost in the weeds. And in my view, the difference between a good engineer and a great engineer is the questions that they ask themselves when solving for a particular problem. So behind the zeros and ones, we sometimes forget that, at least for now, we're defending against humans, not computers. And the natural preceding questions are, well, who are those people and what might they do? And these are the questions that I think we really need to be asking ourselves when we're deciding where our efforts are best spent in defensive programs. If I could take another example by going back to the father of modern computing, Turing. It was when Turing's team realized that it was the German operators regularly including predictable strings in their encrypted messages that the insurmountable became possible. The Bletchley team probably couldn't have conceived what would have happened with computing in the preceding century, but philosophers as early as Plato could have told you about the humans that would be sat behind those machines. Ultimately, we are creatures of habit, we're predictable, and that's a chink in the armor which defenders have to exploit if they want to succeed. The cyber threat intelligence community do an amazing job of surfacing technical details from breaches, and from this intelligence, defenders can make really valuable inferences about the types of attackers that we're each most likely to face, their motivations, their patterns of behavior. Crucially, the equivalent of Turing's predictable strings found in CTI are TTPs. And TTPs, it's something that we hear about all the time. We're all familiar with the term TTP, or tactics, techniques, and procedures. But since it's so central to the process, it's worth just quickly dissecting. When we look at an adversary's behavioral fingerprints, we describe the goal as a tactic, and this might be something like the acquisition of credentials. We describe their method as the technique, and this could be brute force, or if we have a subcategorization or sub-technique, we might call it credential stuffing. Procedures are the lowest level specific implementations of techniques used by an adversary, and these are really the behavioral fingerprints that we're talking about. So we might see that a particular adversary was observed password spraying domain users with PowerShell over RDP protocols. And when we're looking at threat-informed defense, we're getting as close to the adversarial procedure as possible. So by the time that we were actually going to start rolling up our sleeves and get stuck in with some detection engineering, it's important to note that the differences between detecting something like brute force via PowerShell over RDP versus brute force via command shell over any other protocol, there's a significant difference. And if we had more time, we could go into the details of detection engineering for things like invariant behaviors. But the key takeaway that I would like everyone to leave from this slide is that we're looking to improve defenses in the context of a particular threat actor, and the closer we can get to that detailed procedural implementation, the better. For detection engineering, you have to be incredibly specific. So if TTPs, and particularly the Ps, speak to our adversary's behavioral fingerprint, how do we start to understand their motivations? And the answer is that the global CTI community do an outstanding job and an amazing amount of research to map these behaviors to goals and outcomes, from which underlying motivations become really clear by reading between the breaches. And by analyzing the behaviors and motivations of adversarial groups worldwide, we can start to compile adversary profiles. So what's an adversary profile and how do we make one? Well, to create an adversary profile is to analyze cyber threat intelligence in the context of our own threat landscape and produce a report that details things like the adversaries we're most likely to face, the capabilities of those adversaries, the motivations of those adversaries, and the tactics, techniques, and procedures, particularly procedures used by those adversaries. And it's with these data points that we can start sort of create a starting line to measure and improve our defenses by mirroring or emulating the real world behaviors of our highest risk attackers. It's through this sort of adversary-centric strategy that we can facilitate proactive tools and processes that inform defensive teams about where improvements are likely to be highest value, highest reward. And the process all starts with cyber threat intelligence. So again, natural first question, where do we get the intelligence? Well, there's likely to be a number of viewers today from organizations who subscribe to premium threat intelligence platforms, and many of whom provide the data to simplify this process. Ones that come to mind are providers like Digital Shadows, CrowdStrike, Rapid7 Insights. They all provide pre-structured data services that support organizations in building adversary profiles. We said at the beginning that we would talk a little bit about how to do this for free. So even without a premium-based subscription product, there are plenty of reputable, high-quality open data resources to support this process. Mitre Attack, NCSC, CISA, Malpedia, they all give us at least some of the data points that we need in order to start collating this information and building those kind of adversary profiles. So ultimately, the goal is to filter down the otherwise unmanageable volume of qualitative threat intelligence to just our most relevant adversaries. And our goal today is to show the audience how they could get stuck into threat-informed defense without any of these premium tools. We'll talk a little bit about how an organization could start to build this process from scratch using not a lot more than Python and a few API calls. And really the questions that we're going to be asking ourselves today start with things like what sectors or geographies do we operate in, what technologies do we rely on, what are the data that our adversaries could find most valuable, and how mature are our existing defenses and things. And going back to making the otherwise unmanageable volume of cyber threat intelligence accessible, what we're trying to do is we're trying to create variables through which we can filter down to our highest risk adversaries. So why Fox Kitten? Ahead of today's discussion, we asked ourselves all the same questions from the previous slide, and we won't comment publicly on our specific defensive technologies, but our sectors, geographies, and business are no secret. So we took the latest enterprise attack STIX file from Mitre, STIX being structured threat information expression, and we grabbed the Mitre attack Python module to start asking the dataset some questions. Specifically, we created a Python script to poll adversarial group descriptions for actors known to target organizations operating in European and African markets, specifically technology markets. And of the shortlisted adversaries returned, we compared the latest security advisories published by CISA and TSC, and began to review the qualitative information on motivations for each group in a bit more detail. As an MSSP, the credentials that we use to manage customer environments are our most valuable resources that an adversary might try to steal, and they're also the assets that we're most focused on protecting. So with supply chain compromises gaining popularity, it's important that we continually review the specific threat groups that may seek to exploit those. And therefore, when we noticed that Fox Kitten has a history of initial access brokerage, monetizing access to victim organizations on dark web marketplaces, we ticked all of our boxes. They're targeting peers in our industry, in our locations. We have the data that they'd be potentially looking for, and therefore it's important that we test our defenses proactively such that if we ever were in a real life scenario against Fox Kitten, we can be quite confident that we'll be well protected against it.
Sorry, just to chime in there, Mark. I think you make a very good point there, particularly around the sort of the valuable supply chain assets, and we have a massive reliance on supply chains. I think we obviously spend our time looking at what threat actors we need to be concerned about and building our detection, response, protection capabilities around that. But I'd probably urge people to also look at evolving that into your supplier governance or your supplier review process to ensure that that's something that they're doing ongoing and not standing still, and making sure that they are continually improving, testing, and reviewing really what threats matter to them, and to ensure that they're not compromised.
Yeah, absolutely. So the key takeaway there is, we've isolated an adversary with regional, commercial, and motivational relevance to us. We would recommend that any supply chain provider do the same. The importance cannot be overstated. So when we have all of that in place, we can start to flesh out an adversary profile. And an adversary profile is, it can vary by organization and your own threat-informed defense low-level process, but it should include at least an overview of the adversary. And this can include things like attribution, origin, target sector, and region. A relevance assessment. So for us as a managed service provider, initial access brokers are someone that we're constantly looking at, and observe TTPs. So techniques maps to Mitre IDs, potentially also things like tooling, malware families, softwares associated, any particular campaigns. These all add to the actionability potential from the report or profile that's generated. Again, just to reiterate, it's the P or procedural level that is our kind of highest value asset when starting to replicate these behaviors. But in lieu of a specific procedure, you can look at the techniques and sub-techniques as a kind of guide. I think it was Stuart Peck from Palo Alto who said that no two threat actors and no two organizations are the same, but there's probably some common ground somewhere. If you can't get a procedural detail, working on the technique or sub-technique is it's a good starting place to fill gaps, particularly where you have procedural enrichment for a few of the other techniques. So the real world value that we get out of all of this is the connection between actor, relevance, and attack type. Those data points too often sit in disparate tool sets, and the objective of this is really to bring it all together. If we do it well, we get a strong adversary profile that helps us to prioritize defensive investments, potentially give detection engineers, responders, and red teams clear direction for building realistic attack scenarios. And in short, it should help to turn abstract threat actor intelligence into testable hypotheses from which we can repeatedly test our own defenses with aim to mature. So let's have a look at the actual implementation. Once we've built a kind of an adversary profile. In our case, it was Fox Kitten. We can start to use programmatic methods to turn that intelligence into action. And that's where micro emulation plans come in. And a micro emulation plan at its core is designed to replicate kind of key behaviors, in this case, documented as procedures of a real world adversary in a way that's realistic, controlled, and most importantly, relevant to your organization. Obviously, there are pen tests and red teams and things that you can get, and you might be asking, what's the difference? Well, where traditional red team generally attempts to simulate full attack chains across weeks or months, micro emulation plans should focus on a small number of high confidence slices of adversary behavior, often, no more than 50 techniques at a time, but in a way that's a form of unit test for a specific attacker. Atomic red team tests individually are great tests for an individual detection or what have you, but by chaining them together in the context of a specific attacker, we can repeatedly test for something closer to a real world breach scenario. And that is invaluable when we're looking at getting really mature defenses in place. The idea of what we have on screen here, we've got a Python script that intends to manage the cyber threat intelligence component, which is from which we've distilled our adversary profile of relevance, but also bringing in our validation and test metrics, for which we're using a suite of atomic red team tests, some of which were open sourced, many of which we've developed in-house. And for our defensive standpoint, we've also linked in our Sentinel detection as code repo. From that, we can start mapping the whole way through the life cycle from CTI to emulation and validation to defensive assets. And later on in the chain, these are going to give us the tools that we need in order to start performing gap analyses. So you'll see on screen that I'm just calling this Python script without any command line arguments because I've got them detailed in the script. We're just passing a alias for our group as Fox Kitten. For today's demonstration, we'll be using, and the machine that we're on actually is a Windows 10 VM that we're managing in Azure. You'll see that the script has just gone and fetched Mitre STIX repo, and it's done some extrapolations based on group aliases to the techniques and things that that Fox Kitten are associated with. From here, we can start to generate our kind of detailed adversary profile, but because we also have our atomics, we can map those programmatically to the specific validations of note and relevance. Now, I think it's Pareto's law, forgotten. But the idea that you can kind of get 80% of your value out of 20% of your effort really speaks here. What we've done is we've programmatically generated the majority of our adversary profile, but it doesn't account for and can't account for things like the qualitative enrichment that we did in order to identify Fox Kitten as an initial access broker. So if somebody were to take on a tool set such as this themselves, I would recommend that before getting to the execution point, they just enrich it a tiny bit by hand, just to put in the rationale that specifically ties the threat actor to your organization. In our case, we'd be talking about initial access brokerage and things. But the specific rationale will depend on you and your organization and the adversary that you're running this exercise from. We'll also see in the scripts that we have generated an execution plan, and that's this PowerShell script. We've basically extracted the validation tests of note to our attacker. And if we go and look at some of the kind of specific requirements, we know that Fox Kitten, based on cyber threat intelligence, has valid credentials, and we can start messing around with things like passwords not expiring. We know that they have used command.exe as a password changing mechanism. Well, we can cycle passwords on local account through command shell. We can start messing around with scheduled tasks. We can start doing credential access PowerShell scripts like Empire, Sharp-Hound for domain enumeration things. We can create local app. All of these things are emulatable, repeatable. So again, just to reiterate, we've got a Win10 VM in a virtual domain. It's just very, very simple infrastructure that we've used as our test. But one thing that we've been able to do through Ansible is replicate the audit policies of an image, some other location. Now, I would recommend that each audience member joining this today replicate the specific audit policies of their own domain in a controlled environment that has no impact on production instances. We can see here that things like Defender and other tools that we're not necessarily testing right now are starting to kick in. And these are all things that need to be considered. Are we using the same defensive tools in our test environments? Are we doing this? Are we doing that? Basically, we're trying to get as close to the real world scenario as possible. On the other hand, we might choose to disable Defender ahead of time. We'll get more successful test execution. We're in a higher impact scenario. But it all depends on the requirement that you're working to. Maybe this is the third time you've run it, and at this point in time, you want to see what happens without any defenses in place because they are getting better at defense evasion or what have you. What we're really trying to highlight here is that by constructing so much of this programmatically, it becomes almost trivial to make these minor adjustments and start testing real world scenarios with minor tweaks to see where you get the kind of highest value return. Now, we actually ran this script way ahead of time, just in the interest of our presentation. We ran it yesterday at about 9:50 in the morning. And from there, we've compiled a list of alerts in Sentinel for attacks specific to our adversary of note. And we can start to perform our gap analysis here as to where we were strong and where we were weak. We've seen things like the credential password resets that were mentioned yesterday, mentioned in the file. We can also look at things like how was PowerShell used in order to update credentials, ngrok proxy, how was that abused? We can start looking at base64 encoded commandlets as specific to Fox Kitten and all of these other really important pivot points for testing our defenses in the context of real world procedures for adversaries of note. And I hope the value in that is clear to all of the audience.
I guess to that point, Mark, I think it's probably important there's an element of emulation here to validate that we're detecting and that we have the detection capability in place. But there's also, I guess, an element of identifying, exactly where we're gapped. So not just from our audit policy is going to allow this, so that we've got an opportunity to refine, or as our cyberfire customers will be aware, getting a defense threat that needs to be rectified. But I guess also looking at, actually, here's some of the tactics or some of the procedures that we don't have coverage for that's important.
Yeah.
So because it's, using that previous step, we need to map that out in terms of what we have coverage for, what we don't have coverage for, what's really important, so that we're not just emulating, but we're fine-tuning our detection engineering, our the scoping and implementation of any of our defensive techniques really cover for those items that apply to us.
Absolutely, it's a great point. So by taking on an exercise like this, there are so many domains in which you can identify opportunities for improvement. One of those could be the addition of a new detection specifically for a procedure which we had no coverage in before. It could be the modification of an existing detection to pick up a slightly different procedural implementation of the same technique, which is related. It might be that we need to change our audit policies. There might even be network issues that cause log ingestion delays, which need to be somehow adapted for. But ultimately, the kind of key thing that we're doing here through replicating the attacker's behaviors is we just get all of those insights that it would be too late to get in a real world scenario. We're preempting them ourselves in a kind of controlled environment. And through this way, we get kind of all of the benefits without so much of the risk. That's the objective.
No, indeed. And it's, it can't be stressed enough that, one of those critical steps I think is often forgotten. And I've actually noticed that the Gartner have started to talk about it in terms of their security operations lifecycle. There's having the information up front in terms of threat actors that needs to inform your defense. But, equally important is the need to validate what you're doing over and over again, so that we've seen that in breaches that we've responded to on behalf of customers through our IR team, where that isn't taking place, and to that organization's detriment.
Yeah, absolutely. It also helps to inform kind of value-based assessment. So a really great example of this is in PowerShell event logging 4104, really high volume. If you cloud-based teams are typically ingestion-based pricing models, and for most people assessing whether or not to bring something in as a log source, you tend to look at the cost. There is a really high cost associated with logging PowerShell. there are also a number of things which are borderline impossible to detect without logging PowerShell. And it helps you create kind of more value-based assessments as to whether or not your organization should, based on the threats which you are most likely to face. And those kind of insights are really hard to surface through anything but this. So yeah, there are plenty of ways in which these sorts of exercises can pay dividends. Yeah.
Yeah, and I suppose that's all driving towards developing the target operating model, for your security defenses, your detection and response capabilities, that are tuned to you as an organization overall. So that which is probably a great way for us to jump into our summary as we really wrap up. You might need to click us on there a page there, Mark. But really, what have we covered today? I think we've looked at how external threat intelligence is key to developing our defensive capabilities. We walked through that in terms of understanding what the threat is, to then taking that to that step further to ensure that we're developing our detection capability against that. The same way that we do that for all of our customers, to look at, and the same way we do it internally for ourselves. Because I can't, again, that's critically important for us as an organization to ensure that we're defending ourselves and our customers from the threats that all of us are facing, and then also going as far as then doing the validation. But it's also, as Mark talked about, the importance to understand our threat landscape, because it's unique to every organization. Yes, there'll be crossover with other organizations and similar verticals, similar geographies. And also, we wanted to think about the difference between tactics, techniques, and procedures that Mark talked about at the very start. And adding all that information, how do we apply them to great benefit? No doubt we'll see, undoubtedly, we see that we have cross capability across some of those assessments, but that's all part of building a rich defensive capability. We can do this by analyzing Mitre STIX, as Mark showed, that it really allows us to enrich with qualitative CTI, and that's important to understand the adversaries that are relevant, and importantly to our threat landscape. And obviously combining that with things like Mitre, Atomic Red Team. In this instance, we've used Microsoft Sentinel detection as code. We've used that to build our threat-informed defense automation tool. I think that's important that, like many activities, particularly in cybersecurity at the moment, they go well beyond what can be achieved by a single person. Yes, AI is there to help us. If we look at cloud, the plethora of configuration options are well beyond human comprehension. So it's important that we build tools that can automate this process and speed it up, because we need to act quickly. And then that automation platform needs to facilitate an ongoing, continuous, standardized exercise, so we can evaluate the defense in the context of relevant real-world threats over and over again to keep refining, enhancing our detection capability. So I think just to finalize things, we'll jump into our Q&A. Before I jump into the Q&A, we did run that poll at the very start of the session, and just to share the results there, we looked at how people are using threat-informed defense to defend their businesses. We didn't have anybody respond to say that they've got it fully functioning, but we did have 60% of the respondents saying, actually, we're using it ad hoc in some form to do occasional reviews against the threat landscape. But interestingly, a number also looking at, no, this is not a concept they're aware of or not something that's being implemented. So with that, we'll jump into the Q&A. We have a few questions that have been asked as we've gone through. And I'll start with one that's probably most relevant to what you just talked about a second ago, Mark. And that's around use. And the question is, would you advise against using on production systems? Is it not going to be more relevant?
So there's definitely a discussion to be had against relevance versus risk. I would absolutely advise against testing in production systems simply because of the risks associated. There are a number of emulations which you'll likely have to conduct that are intolerably high risk. You just don't want to start spinning up random domain controllers in your production environment, or replicating Active Directory structure through DC synced and then forgetting about the endpoint where all that information is. It's too high risk to test in production. So the mitigation for that is, in our scenario, we use a combination of Terraform and Ansible to create a kind of virtual domain which is as close in its configuration to our production instance as possible, but we can also spin it up and tear it down and not care about it, right? It takes maybe 20 minutes to build, a fraction of that time to destroy, and it's always built from golden images that are as close to our audit policies as possible. So sure, it's not exactly in production, but that's the point. We still get all of the same logging behaviors, etc. And we get a few benefits as well in terms of the flexibility we get for our billing. So yeah, there is obviously a cost associated with spinning up lab domains and things like that. You can minimize it by testing the exact thresholds through which you kind of get the necessary performance out of the machines that you want to test on. In our case, I think we use B2s for our workstations, maybe D2s or something for our DCs, but you'll find the sweet spot for yourself. I'd recommend managing that as code as well. We're already doing the detection as code, the emulation as code, the infrastructure as code is a very small kind of added portion to that for the risk mitigation you get out of it.
Indeed. And actually, a question that's, I guess, quite linked to that, or linked to your answer, so very relevant, was what skills do you need for threat-informed defense? You covered off a few applications and technologies there. What's the skill set that's required?
Sure, yeah. I think, in security, we are criminal for using different terms for the same thing in job descriptions, and sometimes the same job descriptions for different things. So I probably wouldn't give a particular kind of title like security engineer or analyst. I would also comment that it depends on the amount you're willing to invest. So you could have a two-man team where somebody is kind of your blue teamer and comes with that conventional skill set, and someone is your red teamer. One's doing your detection engineering, one's doing your emulation, and maybe that's the best way to do it within your organization. But ultimately, you could have 10 or 20-man teams all focused on the same subject. It depends on your capacity. The minimum necessary skills that you need are someone who understands how to create an emulation test. Typically, we might see job titles like pen tester, red team, whatever. Equally, you may have security engineers and detection engineers that can do that. On the flip side, you need someone who can engineer effective detections. Security analysts and conventional blue teamers may fit that bill, but it all depends on the person. I've met red teamers who are fabulous blue teamers who are fabulous red teamers. I think you actually need a little bit of both skill sets to really engage with the whole process. So as usual, my answer is it depends. Think about the people that you have in your organization and their capabilities, because you're likely to be surprised by some of them.
Indeed, great politicians ending to that answer there, Mark. So we've got two more questions. I think we'll try and get in the time. The question is, would you recommend using a premium feed? I guess this is for threat intelligence.
You're going to hate me, but again, it depends on your budget, your organization. So it massively simplifies the process, and there are limitations which we didn't discuss in great depth to things like the Mitre STIX data set. If you have the budget, of course, there are benefits where I would recommend getting premium feeds. If you're just getting started and you're trying to figure out if this is something that works for you, start open source, see how far you get with that before you start paying for more enrichment. If you already have some of the tooling from providers who are prepared to give you this data at a fraction of the cost because it's just a bolt-on or what have you, again, that becomes more attractive. So think about your own situation. If you're getting started, just give it a pop with the free tools that we've discussed today. If this is something that you're already heavily invested in, I would just recommend that in the vendors that you engage with, you need to pay close attention to the API documentation before signing up to any particular subscription. You know, sometimes we're a little bit generous with our terminology when we talk about the products that we love and sell, and it's important to try and get a test run for yourself just to make sure that the sort of cyber terms or what have you that the vendor refers to are the ones that will support your own threat-informed defense toolset.
Very good. And last question before we wrap up, does this mean we should focus on procedures and ignore tactics? So I guess that was related to the talk on TTPs and a focus on the procedures.
Yeah, perhaps perhaps in my communication I've kind of made too far of a disconnection between the two, but by looking at a procedure, you are looking at a tactic. Inherently, it is it's the needle tip of a tactic for which there are many different sort of very low level implementations. So by looking at the procedure, you are looking at the tactic. It's just in the kind of most distilled, low level, in the weeds version of a particular version of an adversary's use within that tactic that you can get to. So you're not ignoring tactics by focusing on procedures. It's kind of the opposite. You're getting the most actionable version, particularly when doing things like detection engineering, which require a very high degree of specificity.
Yeah, and I suppose probably to call out that almost hierarchical tree of the sort of breakdown between those, and then there's also an element of the pyramid of pain that comes into play.
For sure, yeah. So going back to what is threat-informed defense and threats not being IPs, domains, or hashes, they are humans. Think about the human on the other side of that computer. What is he trying to achieve? How might he do it? What are the kind of behaviors that he might exhibit whilst doing that? So yeah.
Perfect. Okay, well, I think that wraps up the Q&A. So I think just a couple of things to mention before we wrap up. We go to the next slide, please, Mark. Just to cover off that we have a number of webinars coming up that we've got on screen here. So please use the QR code to register and then and join us on 3 more great webinars and more to come. And then the very last thing to cover off on the next slide, please, Mark, is our Security First conferences. So we have completed all our Security First conferences around Europe, but we are running 2 more in May in South Africa. On the 20th of May, we'll be in Johannesburg. On the 22nd of May, we'll be in Cape Town. So if you're in the area, please sign up, please join for a very worthwhile day of insights from industry experts and peers that we can bring to give you, really actionable insights. That's the way that we focus our webinars. That's the way we focus our conferences, to make sure that there is value to take away that can be instantly actionable or at least planned as part of that. And importantly, also to learn from peers overall. So with that, I'll say thank you very much to Mark for joining me today to walk through threat-informed defense and how we use that to defend not only our customers but ourselves as part of our detection response capability and services. And also thank everybody for joining today and giving us your time for us to walk through that. Thank you very much.
Thanks, all.